Welcome to the session on moments, tilting. The objectives for this session are to solve problems involving rods on the point of tilting. Recall that the clockwise moment of a force F about a point P is equal to mod F times d, where d is the distance perpendicular to the direction of the force. Recall that if the distance is not perpendicular, then we need to calculate it using geometry, and in this case, as we can see from the diagram, the clockwise moment of F about the point P equals mod F times d sine theta. A rigid body, which is on the point of tilting about a pivot, has a reaction at any other support or tension in any other string or wire which is equal to 0. Let's take a look at an example. A uniform rod AB has length 14 meters and mass 85 kilograms. The rod is suspended from a pair of light cables attached to C and D, where AC equals 6 meters and CD equals 5 meters. When a weight is hung at A, the rod is on the point of rotating about C. Find the mass of the weight. Let's begin by drawing a diagram. Here's our rod AB, and since the rod is uniform, the weight acts at the midpoint, as shown, 85 Newtons. The length of the rod is 14 meters, as shown, and therefore the distance from A to the midpoint is 7 meters. Now the rod is suspended from a pair of light cables attached to C, as shown here, and D, as shown here. And since the rod is on the point of rotating about C, the reactionary force at D is 0 newtons. The distance AC is 6 meters, as shown, and the distance CD is 5 meters, as shown here. Therefore, the distance DB is 3 meters. Now the weight is hung at A, therefore we have mg newtons acting at the point A, as shown. And this is the weight or the mass that we're required to find. We also have that the distance from C to the midpoint is 1 meter. So using this diagram, let's take moments about C. Anti-clockwise first. mg times 6 about the point C equals 85g times 1, as shown here. Tidying up gives us 6m equals 85. And solving for m gives us 14.2 to 3 significant figures. Therefore, the mass of the weight at A is 14.2 kilograms. This brings us to the end of this session. If you have understood its contents, you should be able to solve problems involving rods on the point of tilting. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to this topic.